Good morning, everybody, and welcome to our Mathematics 9 class today. Here's our recorded lecture video for Lesson 7.5. Lesson 7.5 is about angle of depression. Yesterday, we have talked about the angle of elevation. It's the angle you form when you look up. So it's the one formed between your horizontal line and your line of sight. Now, this morning, we are going to talk about angle of depression. The angle of depression is similar to the angle of elevation. It is the angle that is formed by the horizontal line and your line of sight when you are looking downwards. Let's start with today's memory verse. It's found in Isaiah 63, verse 15. It says, Lord, look down from the heavens and see. Look at us from your wonderful holy home in heaven. Where is your strong love and power? Why are you keeping your love and mercy from us? Your VCA boosters today is about the different meanings of looking down or look down. Below are some lines about looking down. Give your best in deciphering its meaning. The first is a quote from Jesse Jackson. It says, never look down on anybody unless you're helping him. What do you mean by the phrase look down? Second is in Isaiah 63, verse 15, our memory verse for today. Lord, look down from the heavens and see. And the last quote, you'll never find rainbows if you're looking down. At the end of today's class, you'll be able to do two things. First, illustrate angles of depression. And second, use trigonometric ratios to solve real-life problems involving right triangles. And here's your venture activity. It's a historical note. And let me introduce to you Hipparchus. Hipparchus is considered the father of trigonometry. He was an ancient Greek mathematician who was specializing in Hellenistic mathematics and philosophy. He was also an astronomer and geographer. He used trigonometry in most of his studies. Hipparchus compiled the first trigonometric table. The Babylonians introduced angle measure using a division of the circle into 360 degrees. Also, studied the ratios of the sides of similar triangles and used other properties of those ratios to solve mathematical problems. The ancient Greeks organized trigonometry and made it a systematic branch of mathematics. That is Hipparchus, the father of trigonometry. Sorry. Now, what is an angle of depression? If you say angle of depression, remember the imaginary line that connects your eye to an object that you are observing, you call it the line of sight. Now, the angle of depression is the angle formed from the horizontal to the observer's line of sight to the observer's line of sight of the object below. So if this is the horizontal line and this is your line of sight, the angle being formed is called the angle of depression. So when we look up, we are forming the angle of elevation. And when we look down, we form the angle of depression. Now, here's an example. If the pilot, we look at the tower, an angle of depression is formed. This one, not this one, okay, but this. When the tower man, we look at the airplane, an angle of elevation is being formed. Now, what's the relationship between these two? Now, how are these two related? Based on the illustration, the angle of depression and the angle of elevation form alternate interior angles. These two horizontal lines are parallel lines. This becomes a transversal. So these two are alternate interior angles. And based on the properties of parallel lines cut by transversal, alternate interior angles are congruent. Therefore, the angle of depression is just equal to the angle of elevation. Let us try some problems. How do we solve problems? Given an angle of depression. First, similar with the one we had yesterday, draw an illustration of the problem. Second, label the given details. Third, determine the trigonometric ratio to be used. And the last one is you need to solve the problem. Let's start. I hope you can see my calculator here and also my slide. Problem number 1. Suppose the ranger at the height of 90 feet. Let's start labeling. 90 feet at the height of 90 feet. This one. Sees another fire and the angle of depression, this one is 3 degrees. What is the distance of the ranger's location to the fire? So this one, we are looking for this, the X. Since our angle of depression, this one is 3 degrees, it's equal to the angle of elevation, which is also 3 degrees. So from this angle, our given are 90, the opposite, and we are looking for the adjacent, which is our X. So now, since our given is the opposite and the adjacent, then we are going to use the trigonometric function. That tangent 3 degrees is equal to 90 over X. Let's cross multiply them, or you simply exchange these two. So we have X equals 90 tangent of 3 degrees. Using our calculator, we have 90 tangent of 3 degrees. The answer, oh, wait for a while. Why did I multiply that again and again? Let's go back first. We just need to wait for a while. We just need to interchange these two. So we have X equals 90 over tangent of 3 degrees. Using our calculator, we have 90 divided by tangent of 3 degrees. And here's the answer. The answer is 1 1,717.30 feet. So we say that the distance from the ranger to the fire is approximately 1,717.30 feet. Let's go to the next problem. Problem number 2. From the top of a lighthouse, 55 feet above sea level. So the height of the lighthouse above the sea level is 55 feet. The angle of depression to a small boat is 11.3 degrees. So it's equal to the angle of elevation. How far from the foot of the lighthouse is the boat? So we are looking for this one, our x. Now from here, from this angle, the given is our opposite, which is 55, and we're looking for the adjacent. So review again your SOHCAHTOA. With this, TOA has both opposite and adjacent. So we'll make use of the tangent function. Tangent 11.3 degrees is equal to opposite over adjacent. That will be, opposite is 55, adjacent is missing, x. We just interchange these two. X equals 55 over tangent 11.3 degrees. Let's use our calculator. We have, you can use the ABC if you like. 55 over tangent 11.3. And here is the answer. Approximately, the boat is 275.25 feet away from the tower. Let's go to the third problem. Now here's the third problem. A bus is parked 200 meters away from the building. So here's the building, and there's a bus 200 meters. The building is 285.62 meters high. A man at the top from the building, a man looks at the bus from the top of the building. And the question is, what is his angle of depression? We're looking at this one, the x. And remember, this is just to say with the angle of elevation, x. So, given our angle x, we have our opposite. We have our opposite and our adjacent. So remember your SOHCAHTOA again. It's in tangent where you find opposite and adjacent. So let's use the tangent function. Tangent x is equal to the opposite, 285.62, over the adjacent, 200 meters. Next, we're looking for the angle x, so we'll use the tangent to the -1 function of 285.62 over 200. Let's check for the value of x. Let us use our calculator. We have shift tangent, that's tangent to the -1 function of 285.62 divided by 200. And here's the answer. It's approximately 54.99 degrees. Or if you want to write it as a whole number, we can write it as 55 degrees. Any questions? Feel free to message me in Telegram, okay? Now, let's clear this one. Let's go to problem number 4. Here's problem number 4. From the top of the tower, 30 meters high. It means that the tower is 30 meters high. A man is observing the base of a tree at an angle depression of 30 degrees. So these two are equal, 30 degrees. Find the distance between the tree and the tower. We're looking for this distance. Based on the given angle, that's 30 degrees, we are given with the opposite and the adjacent. So we will be using the tangent function. Tangent 30 is equal to the opposite over the adjacent. Just switch the two. X equals 30 over tangent 30 degrees. Let's solve for our x. We have 30 over tangent 30. The answer is approximately 51.96 meters. 51.96 meters. Why in meters? Because the given is also in meters. So if you'll have the opposite and adjacent, be sure that they are on the same unit of measure. Let's go to the last problem. A man wants to determine the height of the lighthouse, and he measured it from angle A and found that tangent A is 3 over 4. What is the height of the lighthouse if A is 40 meters from the base? So it means that A is 40 meters from the base, and we're looking for the height of the lighthouse, which is X. Now we can write it as tangent A is equal to opposite X over 40. But remember that tangent A is equal to 3/4. So this is tangent A and tangent A. You need to equate both because they are equal. Using the first one, tangent A is X over 40. Using the other one, tangent A is 3/4. So let's cross multiply. We have 4x equals 40 times 3. That's 120. Divide all by 4. Our x is equal to, that's 120 divided by 4. X is equal to 30 meters. So the lighthouse is 30-meter high. This ends today's discussion, and thank you for joining me in class today. If you have questions, feel free to message me in Telegram. Bye-bye, everybody.